Welcome back to you. I'm very excited because we're into the third module of our science course, and this is one of my favorite chapters. This is about chemistry. And a lot of people have a fear of chemistry. It's like algebra. You just say the word and they just think, oh my goodness. But I think you will enjoy this. It may not be the most interesting thing you've ever learned, but you can learn this if you just follow along with me. Remember to pause the video if you need to catch up or you need to think a little bit. I'm moving pretty quickly, so I always want you to know that you can pause your video and think for as long as you need to. If you turn to your student work text, this is page 27. Let me just remind you that I am working with this textbook, and I gave you the citation there in your student book. If you want to follow along with the text, you are welcome to. You can ask your teacher to borrow the textbook if you want to use a copy. So I can shortcut, we are to Module 3 about chemistry, and this is page 27 of your work text. If you are following along in the textbook, you are going to be on pages 76 to 79. And I apologize for if you hear me slurping. I'm drinking coffee and soda also. I'm about to lose my voice, so I'm trying to hold on as long as I can. But if you hear me drinking something, it's my coffee and my soda. I'll try to keep it quiet. Okay, the first term that we need to define is atom. And this is not the man's name. If you have the man's name, that is A-D-A-M. But these sound alike. Atom, atom. But we are interested in the chemical atom. And the definition here is the smallest particle of matter. Matter is just stuff. That still has the properties of the element. And if you need to pause the video, go ahead and do that. If you think about a big block of gold and you start whittling away at the gold, it gets smaller and smaller and smaller. When you get to the smallest piece of that gold, that is still gold, that is an atom. If you look at the end of your pencil right now, at the very tip of the pencil, there are millions of atoms on the tip of the pencil. You cannot see these with the naked eye. You need a special kind of microscope to be able to work with atoms. But there is a model of an atom. It's called the Bohr Model. There are lots of different kinds of models, but I like the Bohr Model. Bohr was a physicist who came up with this concept, and this is definitely the most common type of model that you'll see. So as we go through these definitions, we are going to fill in this Bohr model. But this thing in its entirety, this is the atom, the whole thing. And I'm not sure why it's not letting me draw the square around there. That whole thing is the atom that we're working with. Okay, so let's define electron. An electron is a small particle with a negative charge And this is so important. You need to know that electrons are negatives. They're the minuses. Outside the nucleus of an atom. Okay. So if I look at this model of an atom, this big yellow area is the core, that's the nucleus. I am going to put an electron right there. I'm actually going to put two. Let's draw two of them. So here is an electron, and remember those have what kind of charge? Negative. So we're going to put a little minus sign in there. Those can never go into this area. They never go into the core of the atom. They are only allowed in an electron cloud around the atom. And let me go ahead and define electron cloud, and then I'll come back and we will, I'll try to show you a picture online of what this really looks like. An electron cloud is the region around the nucleus, and remember the nucleus in our model is the yellow area. It's the core, the center. The nucleus of an atom, where electrons are found. If you need to pause the video, please do so. And I want to try to find you a picture of an electron through a microscope so that you can see. The Bohr model is a very good way to study these, but I want you to understand that these are not flat. If you actually see them in a cloud, it looks very different, and this is not really what I'm looking for, but here's a pretty good example of what it looks like. It's not flat and drawn on a sheet of paper. This is a good model. You've got that nucleus, that core, and then the cloud of all these little electrons are around that nucleus. So these are some general pictures. Some of these can get very complicated, so I don't want to. Here's a good one that will sort of give you an idea of what that electron cloud looks like. Because these things are so tiny, it's hard to draw them. It's hard to explain what they look like. I can't just show you one. I have to give you a diagram to explain. Okay, I want to go ahead and skip around just a little bit. Let's go over to the next page, over to page 30. Okay, we're good. We have a model over there to draw to. So let me just go ahead and back up. We'll keep going in order. I'm sorry. I thought I had an idea, but it didn't work. So, okay, an element. What is the definition of an element? An element is a pure substance. And by pure, that means it's not mixed with anything. It is a pure substance with only one type of atom. And elements always have symbols. Now, you and I have already talked about lots of elements. We've studied carbon, oxygen, nitrogen, helium, hydrogen, and we have talked about lots of different things related to those elements. We've even drawn molecules like this one. So what I want you to notice is this, that if I have an element, one atom of carbon, and here's another atom of carbon, and another atom of carbon, and another atom of carbon, that is an element. Okay? Here it is a pure substance. However, if I were to do this, let's leave this one C, and make this one a nitrogen, would that be an element? No. An element is a pure substance with only one type of atom. And how would I write that in a symbol? If that were a molecule, it would be C3, because there are 3 C's, but it would have 1 N. This is not an element because it's not pure. So let's fix this to be pure. We're getting there. Let's make this be a C, so they're all carbon. They're all just alike. That means it's a pure molecule of carbon. So this is C4. 4 of them. But it's pure because there is only one letter in there. Okay. Metalloids. And I've shown you a picture of metalloids, but let me give you the definition first, and then we'll talk about that complicated picture. Metalloids are elements, so they're pure substances with properties of both metals and nonmetals. So they have properties, in some ways they're like metals, and in some ways they're not. In some ways they're like the nonmetals. And here is a picture. This is a periodic table of the elements. And this table shows you all the known elements that there are. Here's hydrogen. Here's helium. Oxygen, nitrogen, carbon. Those are the ones that we've talked about. There are many others here, but those are the common ones, the smaller ones. The metalloids are the ones I've drawn in yellow, and I've given you the names of them over here. You do not need to memorize these. You have boron, right there, silicon, germanium, arsenic, which you may have heard of, that's a poison, antimony or antimony, that is used in gunpowder, tellurium, and astatine. Those are your 1, 2, 3, 4, 5, 6, 7 metalloids, and those are all. You do not need to memorize that. I'm just showing you the periodic table really here. Okay, moving on. So what are the metals? This one you've probably heard of before. If you say that something is metal, this is what you're saying. Metals are elements to the left of the metalloids. And remember, we did those just a minute ago. So if you're looking at the table, and I'm going to abbreviate PT for periodic table. It's spelled out for you right there, so you don't have to write it. These are conductive. They will conduct heat and electricity. If you let these touch heat, they will get hot. Malleable means that they're able to be bent and shaped. You can make horseshoes out of metal because they're able to be bent and shaped. And they're shiny. Okay. So the metals are this area in blue. There are a lot of those. And remember, the metalloids that we just talked about are these. I'm missing one. SB. Wait a minute. Yes. Because it doesn't sound like antimony. So those are the metalloids that we just looked at. The metals are the ones in blue. Okay. All right. So let's talk about the non-metals, the ones that are not metalloids or metals. They're everything else. So these are going to be the gases, and here are some other characteristics. These are elements that are not conductive. So if you want to make something that will not conduct heat, you need a non-metal to do that. They will not conduct electricity. They are non-conductive. They are brittle. Which means they break easily. It's like if you think of peanut brittle, it cracks and crumbles. And they are dull. They're not shiny. So we have hydrogen, which is up here, and then helium, carbon, nitrogen, oxygen. I won't go through all of those, but those are the common ones that we'll talk about. So I wanted to show you where those are. Those are your non-metals. Okay, moving on. We're back to our Bohr model of an atom. We're up to the neutron phase. And remember neutron star? I told you that we will talk about neutrons in chemistry. So here we are. A neutron is a neutral particle. And neutral means that it's not positive or negative. It is a no charge. A neutral particle in the nucleus of an atom. You will find these in the nucleus. Okay. They do not affect the charge, but they do affect the weight of your atom. So let's say that they can make the atom heavier or lighter. If you take neutrons away, it's going to affect the atom's weight. So remember in my last diagram, we drew in the electrons. So let's go ahead and put those in here because I want to show you something a little bit down the line. So electrons are negative. Let's go ahead and put in a neutron. And neutrons are going to go in the center, in that core of the atom. And I'm going to go ahead and draw two of them. But you notice that one of them is a little bigger than the other, and that's okay. That can happen. You can have large ones, smaller ones, but you're giving some weight to that center core. This is not in the cloud. It's in the nucleus. Okay, so the nucleus is that yellow area. Okay, a proton is a positively charged particle nucleus of an atom. And so let's draw in 2 protons in the nucleus. So I'm going to put one here. Let me get my snap to, I'm going to put one there and one there. And those do need to be the same size. So here's a plus and here's a plus, 2 protons. Now here's something that I want you to notice. This is a very important thing about science. What have you heard all your life about opposites? Opposites attract. They're drawn toward each other. So this positive and that negative are going to be attracted to each other. This positive and this negative are going to be attracted to each other. You remember neutrons have no charge, so they don't affect this charge. This is called a stable atom because you've got a positive for every negative. There is a partner for each plus and for each minus. What if you were to see this picture? Okay, this atom does not have a balance because you've got the plus minus here, but here's a plus that doesn't have a minus. So this is called an unstable atom or an ion, and it's heavy on the pluses, so it's going to carry a positive charge. It has more positive than negative. But what we want and what the Bohr model usually shows is this balance, where you have a plus for every minus. And that's generally going to be, let me show you, let me put that back the way it needs to be, and I'll show you the way it ideally is in nature. So this is an atom of helium. This is one atom of helium. And you may be thinking, well, how does she know that that's a picture of helium? And here's the way. If I look back at my periodic table, I'm not sure we're going to be able to see this, but here's helium, and I know from experience that that is number 2. Okay? Helium is number 2. And that tells me that there are 2 pluses and 2 minuses in that atom. Okay? All right, here is the definition of nucleus, which you already know. Nucleus is the yellow part. So what you're seeing in yellow up there is your nucleus. It is the center of an atom. That contains the protons and the neutrons. And every time you write proton, put a plus, because that's a positive, and that will help you to keep track of those and learn them. Neutrons are negative. Protons and neutrons are found in the nucleus of an atom. And you know about nuclear energy. You may have heard about the nuclear plants at Oak Ridge. That's what they're dealing with. They're splitting that nucleus apart, and that releases huge amounts of energy. So nuclear power relates to the nucleus of an atom. And I've led us right into the next definition. And that's the definition of nuclear force. And I'm trying to find here we go. Nuclear force is the attraction between the particles in an atom. So that drawing force between those particles is called a nuclear force. It's the law of attraction between those little pieces of that atom. Okay, periodic law. This one's a little tough to describe, so we'll get it written down. Don't fret about it too much. But this one says when elements, and remember those are our pure substances, are arranged in order by protons. And that's how they fit on that table. Hydrogen has 1, so it comes first. Helium has 2 protons, it comes second. They're arranged by the number of protons. Groups with similar properties. So all the metals go together. All the non-metals go together. Properties are arranged together. Okay. For example, all the metals are together, all the non-metals are together, all the metalloids are together, because they're arranged by groups of protons, numbers of protons. And periodic table of the elements, I am just going to tell you to see the picture. I don't think we need to copy this long definition down. I think that if we just look back at the table on page 29, so see the pictures on page 29, you won't have to write that definition. This is the periodic table of the elements. That whole thing, the blue and the white, is the entire table of the elements. Okay, my friends, that brings us to the end of the terms, so I'm going to stop this video. And you already got a glimpse of this one. When we come back, I'm going to show you how to read the periodic table and draw yourself an atom of carbon. So I'll see you back in the next video. It should be a little more fun and interesting than just the definitions.